हेलो दोस्तों, मैं हूं आपका ऋषि सर और क्लास 10 कनेक्ट में आप सबका वेलकम है। आज हम लाइट के एक रियली अमेजिंग सफर पर चलेंगे। चैप्टर का नाम है लाइट, रिफ्लेक्शन एंड रिफ्रैक्शन। तो आर यू रेडी? चलिए शुरू करते हैं।
Okay, so let's start with a fun question. Have you ever wondered why a shiny spoon sometimes shows your reflection upside down? Go on, try it. It's a bit weird, right? Well, guess what? The answer to this little mystery is hidden right inside this chapter. So, here's our game plan for today. First up, we'll cover the absolute basics of light. Then, we'll dive into how light bounces off mirrors, that's reflection. After that, we'll see how it bends through lenses, which is called refraction. And finally, we'll tackle the formulas and power, which, trust me, are super important for your exams.
All right, let's jump right in. The journey begins. So the first and most important thing you need to know is this. Light always, and I mean always, travels in a straight line. Simple, right? We only see things when light hits them and comes to our eyes. And it's this interaction that kicks off two amazing phenomena, reflection and refraction.
Okay, let's talk about the first part of light's journey, reflection. Think of it like a game, the bouncing game. You know how a cricket ball bounces off a wall? Well, light does exactly the same thing when it hits a shiny surface. It just bounces right back.
So what exactly is reflection? It's really simple. The official definition is the phenomenon of light bouncing back after striking a polished surface, like a mirror. But really, it's just that. Bouncing back. That's the key word, the whole magic trick. Asan hai na? Now, this bouncing game has two golden rules. Listen very, very carefully. Rule number 1, the angle of incidence is always equal to the angle of reflection. Basically, the angle at which light comes in is the exact same angle at which it goes out. Simple. And rule number 2, the incoming ray, the outgoing ray, and the normal, they all lie on the same flat surface, the same plane. Remember these two. They're super, super important.
All right, now let's talk about spherical mirrors. There are two types. First, we have the concave mirror. Its reflecting surface curves inwards, kind of like a cave. See? Concave. It brings all the light rays together to one point, so we call it a converging mirror. It makes things meet. The other one is the convex mirror. Its surface bulges outwards. This one spreads the light out, so it's called a diverging mirror. It makes things pelljana, spread out.
So check this out. Here's what happens with a concave mirror. See this ray diagram? We've placed an object beyond C, the center of curvature. Now watch how the rays travel, and there, it forms an image. Notice two things. The image is real, which means you could actually project it onto a screen. And it's inverted. Yep, it's upside down. And now for the convex mirror. This one's easy to remember because it always, and I'm going to repeat that, it always forms the same kind of image. Virtual, erect, meaning upright, and smaller than the object. This is exactly why they're used as rear-view mirrors in cars. They give you a wide view of the traffic behind you, all packed into a tiny little mirror. So much aya? Okay, question time for you. I want you to think about this. Why is the word ambulance written backwards on the front of the vehicle? The clue is in what we just discussed about mirrors. So put your thinking caps on and tell me in the comments. I'm waiting to see your answers.
All right, moving on. We've mastered the bouncing game of reflection. Now it's time for light's second amazing skill, the bending trick, also known as refraction. This happens when light travels from one transparent material into another, like from air into water. It doesn't keep going straight. It actually bends a little.
So, the official definition is pretty straightforward. Refraction is the bending of light as it passes from one transparent medium to another. You've definitely seen this. Ever put a pencil on a glass of water? It looks bent or broken, right? Well, that's refraction in action. The light rays bend as they move from the water back into the air.
And just like reflection, this bending follows a rule too. It's called Snell's law. Now it looks a bit mathematical, saying the ratio of sin I over sin r is a constant. That constant value is what we call the refractive index. Think of refractive indexes as a bending power score for a material. The higher the score, the more it bends light.
And just like we had two types of mirrors, we have two main types of lenses. First, the convex lens. It's thicker in the middle and thinner at the edges, kind of like a magnifying glass. This one is a converging lens. It brings light together. Then you have the concave lens. It's the opposite, thinner in the middle and thicker at the edges. And you guessed it, this one is a diverging lens. It spreads the light out.
Now, let's see a convex lens in action. In this diagram, we've placed the object right at a special point called 2F. And look, the image forms on the other side, also at 2F. It's real, it's inverted, and it's the exact same size as the object. This is basically how a simple camera works. It forms a real, inverted image on the sensor.
And here we have the concave lens. Just like the convex mirror, this one is predictable. It always forms a virtual, erect, and smaller image. And here's a cool fact. If you know someone who can't see distant objects clearly, that's called nearsightedness, the glasses they wear use a concave lens to help them see.
Okay, guys, let's get serious for a moment. We're now entering the most crucial part of the chapter, the part where all the numerical problems come from. I call it the power play. We're talking formulas and sign conventions, so I need your full attention here.
To solve any problem correctly, you have to follow these rules. It's called the new Cartesian sign convention, but don't let the name scare you. Just think of it like a simple graph from math class. The center of the mirror or lens is the origin, 0, 0. Anything to the left is negative. Anything to the right is positive. Anything above is positive, and anything below is negative. That's it. Clear, Hannah?
And here they are, the master formulas. Now look closely. The mirror formula has a plus sign between one V and one U. The lens formula, it has a minus sign. That tiny little difference is everything. Same for magnification. The mirror formula has a negative sign, m equals minus v by u, but the lens formula doesn't. You absolutely have to memorize these.
So what is this power of a lens we keep hearing about? Well, in simple words, it's just the strength of the lens. It's a measure of how strongly a lens can bend light rays. And the formula is super easy. Power, or P, is simply 1 divided by the focal length, F. It's the reciprocal of the focal length.
And the SI unit for power is called the diopter. We write it with a capital D. Now here's a pro tip that will save you marks. When you use the formula P equals 1 over F, the focal length must be in meters. Always, always check that.
All right, it's your turn again. Time for a quick challenge. Let's say a doctor prescribes a lens with a power of plus 1.5 diopters. My question to you is, what is its focal length? And is it a converging or a diverging lens? Use the formula, do the math, and post your answer in the comments. Let's see who gets it right first.
Okay, let's do a super fast summary of everything we learned. Ready? Reflection is bouncing, and it happens with mirrors. Refraction is bending, and that's for lenses. Converging team, that's your concave mirror and convex lens. Diverging team, that's the convex mirror and concave lens. And the golden rule for problems, sign convention is your key. And of course, don't forget those master formulas.
And that, my friends, was our journey through light, reflection, and refraction. I really hope everything made sense and you feel a lot more confident now. If you have any questions at all, you know what to do. Ask away in the comments. Keep studying, keep growing. Padhte raho, badhte raho. I'll see you in the next one.